Alright, Rebel, doing a Euler's problem here. It's a BC topic. It's kind of like an AB when we did tangent line estimations to figure out where the future height of a function would be. Except this one's even better, more accurate. So here we go. We've got this initial value problem. It says the derivative is equal to x plus 2y. And the height of the function when x is equal to 0 is 0. And we've got to figure out what's the height going to be when x equals 1. And we're going to use a step size of 0.25. Alright, so here we go. First thing you're going to do is we're going to figure out the derivative at x equals 0. And that's going to be, well, x is going to be 0 plus, we've got to do 2 times y. Well, what's the y coordinate when x equals 0? Well, that's 0 also. So that means initially the slope of this thing is 0. Alright? So our graph started at 0, 0. Now what we're going to try to do here next is we're going to figure out where's my height when x equals 0.25. Alright, so here's what we're going to do. We're going to y of 0.25, right, is equal to, it's equal to the current height, which is y of 0, plus, alright, we have our rise over run at x equals 0, which happens to be 0, times how far are we going to run? Because if you do rise over run times run, you get rise, right? So here's your start height, right? And now we're going to rise some amount. So we're going to do 0 plus, alright, how far are we going to run? We're going to run 0.25. Alright, and in any event, the height we're estimating at x equals 0.25 will actually equal the height at x equals 0 because the slope was 0. So we're estimating at x equals 0.25, the height is also 0. Okay? Now things will get a little more interesting. We're going to figure out what's the derivative at 0.25. And to do that, we've got to use our derivative formula here, which says we've got to take our current x value, which is 0.25, and then we're going to add to it twice the current y value, which happens to be 0. And we'll get 0.25. Let me clean up this slide and then we'll proceed. Here. So again, we started at 0, 0, and then we moved to 0.25 comma 0. That's kind of the track we've been taking. And we figured out the derivative at x equals 0.25 was 0.25. Alright, now we've got to figure out what's the height of this function going to be when x is equal to 0.5, right? So you're going to take your current height, which is 0.25, and you're going to add to that your rise over run at x equals 0.25, which is 0.25, multiplied by how far you're going to run, which is another 0.25. And work this out. Let's see if this is doable without a calculator here. 0.25 plus 0.25 times 0.25. Looks like a calculator question. 0.3125 is what that's going to be. All right. But you'd be able to use your calculator, and that's tough. So 0.3125, that's going to be our estimate for the height at x equals 0.5. So this thing's kind of traveling up now, right? We're at a height of 0.3125. And the process just continues. You're going to do y at 0.75 equals your height at 0.5, right? Plus, we're going to take the derivative at 0.5 times how far you moved, which is another 0.25. And that'll give you your height at x equals 0.75. And then finally, to finish it off, we'll have y of 1 equals, we're going to figure out the height at 0.75 plus, then again we're going to add to that the derivative at 0.75 times how far we moved, which is another 0.25, and then that's it. So I'm getting close to my 5-minute limit for upload here, so I'm going to stop right about here, and we'll have the answer in class next time. But I think once you get the process down, a couple steps, it's you can be able to finish it off, no problem. Hope this helped.